Okay, so when we talk about transformations, which is what we're starting today, we're going to take it easy. We're going to take it light. So this, I'm really sorry, this is the function that we use. Actually, it's not even y equals, it's f of x. F of x equals a bx minus c plus d. This is the format that we use to transform linear equations. Now, we're not going to do all of this today. We're not going to do any of the, we're not going to do B or C. We're not going to even look at B or C until Tuesday. So for today, we're going to be looking at f of x equals ax plus d. Now, what does ax plus d look like that we've seen before? Yeah, it looks like y equals mx plus b, and that's exactly how we're going to treat these. We're going to treat a like m, which is slope. We're going to treat d like b, which is our y-intercept. Because there's more than just two things that we can change when we do a transformation, so we have to be able to mess with all four of them. We don't usually see a lot of changes in B, but it could happen, so we got to be ready for it. So what we're going to do is we are going to, so you guys picked up this paper right here, okay? In GeoGebra, you're going to adjust the sliders on this. I probably should have done screen recording instead of camera recording, but whatever. You're going to adjust the sliders so that you can see 2x. So you're going to adjust the A slider so that it says 2. And then you're going to look at the graph. So everybody adjust your slider so that it says, you know what, it says 3/4. Okay, so when we adjust the slider, if you see up here, so this red slider, you may have to scroll up. No, don't drag anything. Don't drag anything. God think of no, it uses the up and down arrows. Oh, it's too late now. If that happens, you're going to want to refresh the screen. And then you click somewhere up here, just please listen to me. You click up here in the top where it's white, and then you use the up and down arrows to get there. Okay? And it might still disappear again. Once you click it, you can actually use the left and right buttons to move it. So let's look at number 4. Number 4 says negative 3/4 x. Okay? Well, negative 3/4 is negative 0.75. So as I moved that, first of all, I see that it was pointing up and now it's pointing down, right? Well, that's a reflection. So I'm going to check, whoops, no, I'm not there. In number 4, I'm going to check reflected. Okay, because it was pointing up and now it's pointing down. So this gray line here is the parent function, and the purple line is the one that we're moving. All right? Now, I can't tell if this is any steeper or flatter. I've had a lot of people uncertain about what steeper and flatter means. So steeper means harder to climb. So if I was climbing up a hill and it was steeper, I would have a harder time climbing this hill. If I was climbing up a hill that was flatter, I'd have an easier time climbing the hill. Okay, 6th grader's going to 6th grade. And then if it was reflected, it would mean I was going downhill. So I'd be rolling down the hill instead of climbing up the hill. Okay, so this one is going downhill, but it's kind of hard for me to tell if this is steeper or flatter. So I need you to focus up. So if I can't tell because they're going in different directions, what you can do is, you see how it's negative 0.75? I can move it so that it's positive 0.75. Now can you tell if it's steeper or flatter? It's flatter, so I'm also going to check flat. Now, if it was shifted up or shifted down, this red dot would have moved. So you see, like, let me show you. If I change D here, it shifts up and shifts down. But the dot didn't move. So I'm not going to check anything for shifted up and shifted down. I might only have one thing, I might not have something checked in every column. But can I have steeper and flatter checked? No. Could I have shifted up and downs checked? So I could have one from each one, but I don't have to have one from each section, okay? So I'm going to give you all 10 minutes to go through, and you're going to mess around with GeoGebra, and you're going to check these things. You're going to check all of them, up to 10. If we finish early, that's... Yeah, they all did. These are the answers, so go ahead and check and see if this is what you guys got. Now, I saw a bunch of people that had something checked here. On this one, what I saw was two lines like this. This one was parallel to the parent function, as was this one. And if they're parallel, it's not steeper or flatter. They're equally steep or flat. So you shouldn't have anything checked there.
Number 8 is wrong.
What do we think? At this point, y'all can shut down your computers. We're not going to use them anymore. We were just collecting data here. Unless you want to do more at home, but I mean, obviously not right here. 7 was steeper and shifted up. Okay. So, here's what we're going to do now. All right? Stop it. You are going to go to the back. Stop. You're going to go to the back, and you're going to write on the section the part of the paper that says reflected, right here, where it says reflected, you're going to write down every one of the ones you checked in the front that have reflected checked. There are 4 of them. You have 1 minute to write those down. Once you're done writing them down, I want you as a group to look and see if you think you know what the pattern is. So 4 of them had reflected checked. You're going to write down those 4 problems. You're going to write the equations of them. Sorry, just the equations, not the numbers, the equations. Oops, I put that in the wrong place. Okay, 13 seconds left. Okay. All right, so let's take a look. These are the 4 that I found. Did y'all have a chance to talk about it? What do you think it is? What's negative? The slope is negative on all of them. Okay, so let's bust out your notes. We're gonna write some stuff down about this. Okay, so over here where it says increasing m. Okay, well I'm sorry, where it says changing the sign of m right here. Okay, when we change the sign of m, that causes a reflection. So we're gonna say reflected. Okay, so when m is positive, our line points uphill. Okay, when m is positive, our line points uphill. When m is negative, what does our line do?
Downhill.
Anybody else? When m is negative, our line points downhill. Okay, so I'm going to write this down. I want y'all to look at it. It's okay. You can write below it. There's plenty of space down there. So 3x, negative 3x, I transform that into positive 2x. Is that a reflection? Well, if negative 3x is pointed downhill and positive 2x is pointed uphill, yeah, it is, because this was pointing downhill and now it's pointing uphill. They're reflected. So what I'm saying is I'm turning this into that. I had to change the sign on it to change it. Do they have different signs? Then they're a reflection. So I know like last year, like when y'all did reflections before, you're kind of used to them looking like this, where you take this and it's got to look like that. When we say a reflection in like a function reflection, we're saying that it's instead of being negative, it's positive, or instead of being positive, it's negative. Okay?
They say about the opposite.
Okay, yeah. So you'd think it would be the opposite, but remember what happens is the sign changes. That's what makes it a reflection. The sign changes, okay? All right, I want you to now take 2 minutes, but That's to talk and write. You're going to find all the ones that were steeper and flatter. There are 4 that were steeper and 4 that were flatter. I want you to write those down, the equations, and then look at them and see if you can figure out a pattern. Okay, so as I listen to you guys talk about this, I've heard a couple of groups say the flatter ones are fractions. So, let me introduce a little bit more evidence to you. Now, consider again. Those are fractions, right? Okay, say it again. He says these are more than 1 and those are less than 1. What do you guys think? Does that sound right? But -4 is not more than 1. Okay, but didn't I already deal with the negative? What does the negative mean? The negative means it's reflected. So I'm not worried about the negative, I'm worried about the number. So let's grab your notes, let's write. Okay? So we need to talk about this value right here. It's called absolute value. Y'all remember absolute value? Absolute value is a number in bars. It means how far from 0. So it means how far is a number from 0. Okay? So, as an example, the absolute value of 3 is 3. The absolute value of -3 is 3. Because both of those numbers are 3 hops away from 0. So when we think about the slope getting steeper or flatter, we think about the absolute value of the number. We don't include the sign. The sign tells us something else, okay? So when I increase my slope, I get steeper, okay? So the absolute value of m is bigger than 1, okay? Than 1. Bigger than 1. Doesn't have to be a whole number. It can be a decimal. So like, for example, 2x, if that turns into -3x, is this number bigger than this number? Is 3 bigger than 2? Then 3 is steeper. Remember, the negative tells me it's pointing downhill. So the negative does something else, but the number, the 3 and the 2, that's what tells me which one's steeper. Okay? Now, likewise, if it gets flatter, that means m is getting smaller. So the absolute value of m is between 0 and 1. So, for example, if 2x is transformed into half x, is this number smaller than the first one? Then it's flatter. Okay? Okay, now, I'm going to just go ahead and spoil this for you. I want to show you this. Y'all can write it down. I'll let y'all write it down on Monday. Okay, let's take a look at this. When the ones that were shifted up, these are the ones that were shifted up, and these are the ones that were shifted down. Yeah, so what is this part of the equation? The y-intercept. Thank you. Okay. When I shift it up, the y-intercept is positive. When I shift it down, the y-intercept is negative. So if I shift up, B is more positive. That's IVE. I don't know what happened there. Okay. So x plus 3, if I transform that to x plus 5, is 5 more positive than 3? Then it went up 2. X minus 1 transforms into x plus 4. It went up 5. You see? All right. When I shift down, Yes, I know. When I shift down, what do you think B becomes? B is more negative. So x plus 3 might turn into x plus 1. 1 is more negative than 3, so it went down 2. X plus 1 might turn into x minus 6. Minus 6 is more negative than positive 1, so it went down 7. Okay, the last thing I want y'all to write down under this note about steepness, the sign of M isn't used when determining steepness. Okay?